إذا الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ.
Assalamu alaikum and welcome to another explosive and exciting episode of the ITV Math Show. I'm your host and presenter, Muhammad Kota. You are tuned to channel 347. Okay, we have been doing circle geometry, and like we said in our previous episodes, that we had thousands and thousands and thousands of calls and emails from across the country, in fact even across the borders, that said, Mr. K, when are you going to be doing circle geometry? So we are now in episode 2 of circle geometry. If you missed episode 1, go onto the itvnetworks.tv website, click onto the KWay logo on the top of your page, double click, and you will get all the previous episodes. Now, just to recap quickly what we've done in the previous episode, we started with all the theorems that you, the grade 11 or 12 learner, remember circle geometry is for grade 11s and 12s only. So, if you missed the previous episode, we have covered all the theorems from grade 5. We started with an introduction of geometry and what are all the theorems that are required for you to know in order for you to attack a mathematics rider. And what did we explain to you? What was a rider? A rider is a complex geometric shape with unknowns that you need to solve. Okay, so we didn't complete in the previous episode. We only completed until number 6 in circle, in cyclic quadrilaterals or in circle geometry. We're now going on to number 7. And as I said in the previous episode, I'm not going in the order of the theorems. Okay, so I'm just giving you all the theorems that are required for you to know under circle geometry. So let's get started, guys. I hope you guys have got your pens, your papers, your books, and I hope you guys have opened up a file and started taking down all these notes. Okay, we're now doing number 7, 8, and 9. So I've just drawn the diagrams. I'm going to now explain to you each one of these theorems. Okay, before we actually start attacking, and I'm going to do some graded set of riders, meaning that I'll start you from easy, going up to the most difficult or the most complex one that you could see in the exam. Okay, so let's start here with number 7. There's a circle. O being the center of the circle, you have a tangent. Now remember, a tangent is a line that touches the circle or touches a function at one point. You can see it touches at one point. So you always know that this is a radius. And the theorem that when you see this shape in your exam, you know that a radius is always perpendicular or 90 degrees to a tangent. So here we go. We say radius 90 degrees to a tangent. Okay, or line. You can also use it as line drawn from the center of a circle to a tangent, meets it, is perpendicular, or meets it at 90 degrees. Now, not only is a radius 90 degrees, we know that a diameter is twice the radius. So a straight line going through the center of a circle, we all know, is called a diameter. So whether it is a radius or whether it is a diameter, it will always meet a tangent at 90 degrees. So the first thing you do when you see a rider in your exam, if you see a tangent, always look for a radius or a diameter that meets that tangent, and immediately, in 99% of the cases, it will not be given to you as 90 degrees, but you got to imply it. Immediately you go onto your diagram, you put 90 degrees. Why? Because it follows the theorem that a radius is always 90 degrees to a tangent. Okay, so take this one down. Let's now go on to the next one. A diameter subtends, and I explained to you in the previous episode what is the meaning of the word subtend. You take your fingers, you put it at the end of the two lines, and you follow the line through to where it meets at the circumference. So here we go. We've got our fingers on the diameter. The diameter subtends a 90 degrees at the circumference. So the theorem here would be a diameter subtends 90 degrees at the circumference. Your teachers will also tell you that when you are writing your reasoning, you could write it as diameter subtends 90 degrees at the circumference, or alternatively you could use what they use as angles in a semicircle. Now, as you can see, that this is a semicircle. Here is your semicircle. So, angle in the semicircle at the circumference is 90 degrees. Okay, so these two mean exactly the same thing. So just to quickly recap, a radius meets a tangent at 90 degrees and a diameter subtends a 90 degrees at the circumference. Okay, let's go to our second last one. Okay, it's the last one on the board, but it's the second last one in terms of our theorems before we actually start doing our riders. So guys, pay attention. The last one is one of the most crucial and the most critical ones that a grade 11 or 12 needs to know. The minute you see a tangent and you see what we're going to call in studio, or just for explanation purposes, a cyclic triangle. Cyclic triangle means all 3 points of the triangle must touch the circumference. So there's a triangle, all 3 points touching the circumference, and it meets a tangent. And we know that this here is called the tangent-chord theorem. So I'm just going to write it here. Tangent, tan for tangent, chord, tan, chord. So here we have the tangent-chord theorem. And what does this theorem state? That the angle between the tangent and a chord, so here we go, I'm just going to highlight it, angle between a tangent and a chord, so that's the angle between tangent and chord, is equal to the angle subtended at the circumference in the alternate segment. So this would be the first segment here, this would be in the alternate segment. So angle, this is the actual theorem. What does it state? That the angle between the tangent and the chord is equal to the angle subtended at the circumference in the alternate segment. So obviously we know if this is 80 degrees from here to here, if you measure that and that gave you 80 degrees, and if you measured this angle here, that angle would also be 80 degrees. The same would apply on the reverse side. If this was 60 degrees, angle between tangent and this chord would equal to the angle subtended at the circumference in the alternate segment. And that angle there would be 60 degrees. And obviously here you would know, if you had to complete this, 60 plus 80 is 140, and angles on a straight line add up to 180 degrees. So 60 plus 80 is 140 plus 40 will give you 180. And we know we're right because sum of angles of a triangle also add up to 180 degrees. So we've just justified, we have just proven that angle between the tangent and chord is equal to the angle in the alternate segment at the circumference. So please guys, make sure that you understand these and that you take them down. Okay, let's now go on to the last one. I'm now going to erase. I'll leave those two on the board for now before we start going into application. So this is very important. Okay, so let's get started. Number 10, watch this one. You have a circle. You've got the center of a circle. Now you've got two tangents. You've got a tangent here, stopping at a point, and you've got another tangent going here, also meeting at that point. Now, okay, these are supposed to be straight lines. I'm just drawing them freehand. So these are two tangents. Now, two tangents meeting at a common point outside the circle. So we've got two tangents meeting at a common point outside the circle are equal in length. So the tangents are equal in length to where they touch the circle. So obviously this line goes on to infinity, and you can physically see that this tangent and this entire tangent can never be equal, right? But they are equal in length to where they touch the circle. So two tangents meeting at a common point, outside the circle. There we go, two tangents meeting at a common point outside the circle are equal in length, Can we just stop there? Can we just say that these two tangents are equal in length? No, they are equal in length to where they touch the circle. So that piece there, if this is 10 units, that would be 10 units. Now something that's also interesting to remember, that you've got two tangents here. If that is 10, that is 10. Generally in a diagram, you're going to have a line drawn meeting these 2 points. You're going to have a chord that meets these 2 points. What does this become? The minute you see that and you see a chord that meets the 2 points where they touch the circle, this forms an isosceles triangle. It forms an isosceles triangle. And what do we know about an isosceles triangle? That the two lengths are equal, that the two sides of an isosceles triangle are equal. Hence, what would that imply? That would imply that this angle, the two base angles, the angles opposite the given sides are equal. Okay, so make sure that you have all of these down. We're gonna stop here with theorem number 10. Take them all down. Let's start with one rider. I'm going to put an easy one up before we cut for an ad break. Let's put up a rider for you, and let's see during the ad break whether you can do it. When we get back, we'll actually do the solution as usual. Okay, I think if you have been watching the show, I think you guys know the drill by now. You need to pay attention. After we've taken everything down, we will give you a chance for you to, after I've explained it to you, we will give you a chance for you to take it down, and then we cut for an ad break where you can start practicing, just to basically test your skills. Okay? I hope you guys are enjoying the show, and I hope that you guys are understanding all of these theorems. So let's start with rider number 1. I'm just going to put it up on the board. I'm going to put it up on the board, and it's a very simple one. We're starting off with, let's have a look. Let's put the example number 1. Let's draw a circle, and let's draw what the shape would be. I want you guys to take it down with me. As I'm drawing it, I want you to draw it in your books as well. So you know you need to work a little bit fast. Remember here at ITV, we work fast. Speed, accuracy, neatness. Okay, so O being the center of the circle, that is 60 degrees. They call this D1, D2. They call this C, X, Y. They call this A1. That is 20 degrees. And this is B. Obviously, you need to find the value of X, Y, Z. X, Y, Z, find the value of X, Y, Z. How many marks? 6 marks. Remember, I'm going to show you how to attack. You try it now during the ad break. When we get back, I'll give you the solution. Enjoy your break. Assalamu alaikum and welcome back to the ITV Math Show with me, your host, Mohammed Kota. Right? We started off before the ad break with a rider. I gave you an opportunity. We gave you guys 3 minutes to try and solve for XYZ. We gave you a rider. If you guys have just joined the show, we have completed all the theorems. We've explained to you all the theorems that are required for you to know from grade 5 right up to grade 12. Okay? Here we go. We're going into a problem. Now, before we actually get to the problem, I want to teach you a technique. Okay? Many of you say, we don't know, Mr. K, we don't know where to start. We have absolutely no clue. We see a diagram, we just see lines, we see numbers, and we don't know where to begin. Now, it's a very simple, geometry can be one of the easiest topics, and you can score full marks if you know how it's done. So, what is the process? How do you rationalize? How do you process? How do you understand the diagram when it is given? What do you look for? Before I go into the solution, I'm going to teach you a technique of answering a geometric rider. And it's a very simple, logical explanation. You have got laws, you've got a diagram, you've got a whole lot of lines, and you've got laws. You've got knowns and you've got unknowns. Your unknowns being X, Y, Z, your knowns being 60 and 20. Now, this is a basic diagram. Obviously, we're going to apply the same laws to more complex riders. But hear me out. You know you need to solve an unknown. You are on a journey. You are on a journey to solve an unknown. You are traveling from Johannesburg to Cape Town, for example, 1,500 kilometers apart. Common sense, you need to get to an unknown place. Where do you always begin? You always begin with the known. You begin with where you are at, what is known. So obviously, if you are on a journey from Johannesburg to Cape Town, where do you begin? Do you begin in Cape Town? Common sense. You begin in Johannesburg, where you are at. So you always start in geometry, start with the known. So let's put it here, rules. Let's put a little bit of rules. We say we start with knowns. What is your known here? You've got two knowns. Whether you want to start with the 20 degrees or you want to start with the 60 degrees, it's entirely up to you. We need to start with knowns and move towards the unknown. Rule number 2. So rule number 1, you start with your knowns and you move towards your unknown. Now in real life, if you are on a journey and you wanted to start from Johannesburg going to Cape Town, you would need a vehicle. You can either go by bicycle, you can take a walk, you can take a train, you can take a plane. There are many ways to get to Cape Town. So you need a vehicle. And what is your vehicle in geometry? Your vehicle in geometry are your laws. Your vehicle in geometry are your theorems. So you use the theorems as your vehicle. So let's put it as your vehicle. So we start with the knowns, moving towards the unknowns. We use our theorems as a vehicle. Step number 3, we identify what's given. So let's put there, we identify what's given. So we identify the theorems even before we begin with our problem, because we will have a map. It maps it out for you. And then, obviously, now we all know to get from Johannesburg to Cape Town, there are many routes. So now you select a route, a shortest route. And that's it. It's a 4-step process. We're going to select the shortest route to get. Many ways to get from Johannesburg to Cape Town. We can take the garden route, the most beautiful scenery. You can take the scenic route, which will take you probably 3 to 5 days to get to Cape Town. You can go by train, which might take you 2 days. You can then choose your car. Many different routes. Whether you want to go through KwaZulu-Natal, whether you want to go through the Free State, entirely up to you. But obviously, we want to get to our destination in the shortest possible time. So we're going to choose, we're going to elect, or we're going to select the best, shortest possible route. So we're going to select the shortest route. So here we go. Let's get started. Let's attack. Let's identify. Now obviously I'm doing this just as an introduction. When we do our proceeding riders, I'm not going to go. We're just going to go directly into application. These are the mental processes that I will be using in order to attack that scenario. Now, we start with the knowns. We got a 20, we got a 60, we've got a 20. We need to move to our unknowns. Where's our unknowns? X, Y, Z. We use our theorems as a vehicle. Let's identify what's given. Let's see. We've got a diameter. So all our rules with regarding to a diameter will apply to this problem. There's no tangent here. As you can see, there isn't a tangent, no tangent. So all the rules with regard to our tangent will be left out. The only rule, we've got a diameter. What else do we have? We've got radii. Remember, radius. The plural of radius is radii, and we know that radii are equal in length. And the minute we have radii, what else do I have? I have a triangle. Two sides are equal. Hence, what does that imply? It implies that we have an isosceles triangle. Remember, this here now becomes an isosceles triangle, and that's going to help us, guys. It's going to help us. It's going to help us tremendously in getting to our solution. So let's get started. Let's start with the diameter. Identify what's given and let's select the shortest route. And what did I say? The minute you see a diameter, start including your 90 degrees. So if this is my diameter, we know that a diameter, according to our theorem, a diameter subtends a 90-degree angle at the circumference. So that must be 90. Although it's not given in the shape, you got to include it. And the minute you get an angle and you're confident that that angle is correct, go in and put it in the diagram, because that's going to help you to solve. So the first thing that I'm going to do, you could have started anywhere. This is just my method of doing it. I started with the diameter, I subtended a 90 degrees. I know there's a triangle here, so obviously I'm going to solve for y first. So we know the first thing I'm going to say, angle B, angle CBA. So CBA is how much? Is equal to 90 degrees. That's the first statement I am going to make. You could have started anywhere. Okay? There's no rigid rule as to the order in which your theorems or your reasoning must be given. As long as you can justify what you... That is why mathematics is so important. Because mathematics teaches you the skill not to just make a statement. The minute you make a statement, whether it's in real life, in a real life situation, you accuse someone in life, you call him a liar. The first thing the judge is going to ask you in court, why are you calling the man a liar? Give me a reason as to why. So the minute you make a statement, you've got to give a reason. So, we made a statement, CBA is 90. What is the reason that you are saying that CBA is equal to 90? Because you can say angle in a semicircle. Or you can say a diameter subtends a 90 degrees at the circumference. So now you'll get a mark for that. That is worth 1 mark. Why? You've made a statement and you've justified it with a mathematical law. Not something that just came to your head. With a mathematical law. With a theorem as a justification. So we got CBA is equal to 90. Okay. So therefore, angle Y is equal to, if this is a triangle, 180 minus 90 plus 20. 90 plus 20. 180 minus 90 plus 20 is 110. 180 minus 110 is 70 degrees. So we know that this is 70 degrees. Why did you say that it's 180 minus 90 plus 20? Because we know that sum of the angles of a triangle is equal to 180 degrees. That is why we use 180 minus the sum of these two angles. So now that we've got that to be 90, we've got 70, we've got 20. We now need to get x, we need to get d2, we don't need to get d2, and we need to get z. So let's go under C. This is an isosceles triangle, and how would you prove it? You would now say OD is equal to OC because they are radii. So OD is equal to OC, radii, therefore triangle ODC is isosceles. So if it is isosceles, therefore x is equal to 180, sum of angles of a triangle, minus your given, minus 60, divided by 2, because these two angles are equal. Isosceles triangle. Sum of angles of a triangle. Sum of angles of a triangle equal to 180. So what do we have? Angle X is equal to 180 minus 60, 120 divided by 2, 60 degrees. So X is equal to 60. So obviously, if this is 60, X is 60, D2 will also be 60. How much will Z be? Z is equal to, what do we know? The exterior angle of a triangle is equal to the sum of the interior opposite. So exterior angle equal to the sum of the interior opposite. Angle Z is equal to 60 plus 60, which is equal to 120 degrees. Or you could have used adjacent supplementary. I think that would be the better one to use. Right, we're cutting now for an ad break, guys. Make sure that you've taken all this down. Angle Z is equal to, let's use it this way, 180 minus 60, which is equal to 120 degrees. Adjacent supplementary, meaning sum of angles of a triangle add up to 180 degrees. Boys and girls, we're going for an ad break. When we get back, we're going to do more complex riders. Stay tuned. Assalamu alaikum and welcome back to the ITV Math Show. Now before the break we did a rider. I gave you guys a geometric rider and we needed to solve for x, y, z. It looked a bit hectic towards the end when I gave you all the justification. I'm just going to quickly recap on how we attacked it. Okay, we took a diagram. We said we needed to find the value of x, y and z. So we started with the diameter. We know that the diameter is 90 degrees. It subtends 90 degrees at the circumference, and that was the first statement. Angle CBA. Let's put that as B. CBA is equal to 90 degrees. Why? Angles in a semicircle. Therefore, angle Y, this is a triangle. So angle Y is equal to, we know sum of angles of a triangle add up to how much? 180. So it's 180 minus 90 plus 20. 180 minus 90 plus 20. 180 minus 90 plus 20 is 110. 180 minus 110. Y is equal to 70 degrees. Now, we now needed to get to x. We know that this was 60 degrees. That is a radius. That is a radius. And we know that radii are equal in length. So now, 180 minus, that's an isosceles triangle. Hence, these two angles are equal. If that is x, angle D2 is also x. So therefore, we can say 180 minus 60 divided by 2 to get the value. These two angles are equal. There we go. 180 minus 60, sum of angles of a triangle, divided by 2 because it's isosceles. So 180 minus 60 is 120 divided by 2. X is equal to 60 degrees. And we had y was equal to 70 degrees. We now needed to get to z. We know angles on a straight line add up to 180. So z is equal to 180 minus the 60. Adjacent supplementary. 180 minus 60, z is equal to 120 degrees. Right, so I hope you guys got that one right. Let's now go on to, we're now picking up the pace and we're now going on to example number 2. So this segment as well as the final segment of today's episode will be dealing with riders. We will continue with more complex riders in our next episode. So stay tuned to ITV and keep your dials locked onto channel 347. So example number 2. Take this diagram down. As I am taking it down, I would like you, the viewer, to take it down with me so that you know exactly what you are doing. Okay. Let's draw a diameter there, and we draw another diameter there, and we draw we draw a bow tie. Now, as you are drawing, you are already identifying a theorem. That's why it's always so nice, or it's advisable that you always redraw a shape. Because as you are redrawing it, you are already picking up on theorems that you were taught. Already, before the shape is already complete, we already see the bow tie. And we already can identify that certain angles are going to be equal. Okay? And we do that, and we do that. Arrows represent parallel lines. These two are parallel. We've got A, B, P, C, D. We've got O1, O2. We've got this angle to be 140 degrees. B1, B2, that's angle Z. That is Y. That is X. And that is D. Right. They say AC and BD are diameters. AC is a diameter. That means that would imply. Why do they tell you that AC and BD are diameters? Because they want you to use your theorems of diameters, number one. And another reason why they tell you it's a diameter, because it implies that O has got to be the center of the circle. O has got to be the center of a circle, because a diameter is a line which runs through the center of the circle. If it doesn't run through the center of the circle, what is the term that we use? A chord. A chord is a line from one end of a circumference to the other, but doesn't go through the center. A diameter is a line from one end of the circumference to the other end of the circumference of a circle, but must go through the center. So hence, when they tell you that AC and BD are diameters, they are implying that O is the center of the circle. What other information do they give us? They tell us AB is parallel to CD. AB is parallel to CD. By them telling you that, they are already informing you. Use your rules of parallel lines in order to, as a tool or as a vehicle to get to your answer. So basically what they tell you in a statement is already giving you a clue. It's pushing you ahead as to what theorems you can use in order to solve your problem. And they tell you that they meet AC and AC meets BD at O. AC meets BD at O. So obviously, again, trying to imply to you that O being the center of the circle. What are we required to find? As you can see, X, Y, Z. X, Y, Z is what we are required to find. Okay? Question says, find X, Y, Z. Now you'll notice that in my handwriting I always put a line through the Z. Some of you might be asking the question, why do I put a line? Because I use it for my own benefit so that I do not confuse it with a 2. So if I had to write the number 2, it could be a 2, it could be a Z. Whenever I write the alphabet Z, I always write as a Z with a line going through it so that I'm able to identify and I don't get confused when working it out. And hopefully I would expect you to do the same in your exams. So find X, Y, Z. Again, let's study the problem first. Let's go through. Start with the knowns, moving to the unknown. Start with my known. Which is my only known? 140 degrees. Which are my unknowns? X, Y, Z. Theorems. Let's study the diagram. What's given? We're given a diameter. Is it subtending any angles? No, not yet. What else do I have? Besides having a diameter, I've got parallel lines, so I know I'll be using alternate angles. What else do I have? I have angles around a point. What else do I have? I've got lines crossing each other, so I've got vertically opposite angles. What other diagram do I have? I've got a big cyclic quadrilateral, A, B, P, C, cyclic, all 4 points. So we know opposite angles of a cyclic quadrilateral are supplementary, or they add up to 180 degrees. So I've got a host of theorems that I can get to my answer. You decide where you'd like to start first. Let's start with where I would start first. I know that this is 140 degrees. That's O1. If this is 140 degrees, therefore that must be 40. Agree? Angles on a straight line add up to 180. And as you're going along naming them, you can write them as reasons. So I'm going to say angle O1 is equal to 40 degrees. Whether I use it or whether I don't use it, it's immaterial. But the more information I have on my diagram, the easier it's going to be for me to get my unknown values. So O1 is equal to 40 degrees. And why did we say that? Adjacent, supplementary. Angles on a straight line add up to 180 degrees. I also identify that I've got radii. I know that that side is equal to that side. Why? Because radii are equal in length. Hence, what does that imply? If I've got radii, 2 radii equal, and I've got a triangle, I can then conclude that this triangle is isosceles. So now I will say OA is equal to OB radii. Therefore, triangle OAB, let's just write this A better. Triangle OAB is isosceles. And it being an isosceles triangle implies what? That the base angles are equal. Therefore, angle A is equal to angle B1. Isosceles triangle. Therefore, X, which is A, X, which is angle A, is 100, using sum of angles of a triangle, is equal to 180 degrees minus 40, minus that 40, 180 minus 40, divided by 2, because these two angles are equal. So it's 180 minus 40 divided by 2. Sum of angles of a triangle. Sum of angles of a triangle equal to 180 degrees. Therefore, X is equal to, guys, 180 minus 40 is 140. 140 divided by 2 is 70 degrees. So X, guys, is equal to 70 degrees. So we've got this one here to be 40. We got X to be 70. And like I said, the minute you get an answer here, you put it directly into here, onto your diagram. Now we've got alternate angles, guys. These are parallel lines. AB is parallel to DC. AB is parallel to DC. It was given to you. Therefore, angle Y is also equal to 70. The Z shape These two lines are parallel. So if x is 70, y must be 70. Alternate angles. Alternate angles are equal. So if this is 70 degrees, that is 70 degrees. Okay, guys, we are approaching our ad break before our last segment. Let's now get to Z. I also said that ABPC is cyclic. ABPC is cyclic. Why? Because A touches circumference, B touches circumference, P touches circumference, C touches circumference. What do we know about the opposite angles of a cyclic quad? Go back to your theorems. The opposite angles, are they equal or are they supplementary? Go and check. Yes, you are right. They are supplementary. So therefore, angle Z is equal to 180 minus 70. And 180 minus 70, 110 degrees. Why did you say that? Because the opposite angles of a cyclic quadrilateral are supplementary. They are not equal, they are supplementary. Supplementary means that they add up to 180 degrees. So guys, I hope you took down all these reasonings. I hope you took down the problem and you understood it. When we get back from the break, we're not giving you a rider to do for the next 3 minutes. Take a bit of a break, try and process what has just been explained to you. When we get back from the break, we will continue, we'll round up the show with some more hectic riders. Enjoy your break. Assalamu alaikum and welcome back from our ad break. We are busy with cyclic quadrilaterals and circle geometry for grade 11s and 12s. My appeal and my hope and my wish is that today and yesterday's episode or our previous episode helped you to demystify geometry, circle geometry. Like we said, circle geometry, very difficult for many of you to be able to identify. We've went through some of the steps, rules. This was the approach. Start with the knowns, moving towards the unknown. Use our theorems as your vehicle. Identify what's given and select your shortest route. Now, when you are taking down your problem, it doesn't need to be in any order. As the answers come to your head, or as you start identifying theorems, make a note of it there on the side. There isn't a rigid structure in which it should be answered. As long as you are giving justification to what you are saying, you will get your full marks. Right? Example number 3. We've done example number 1 and 2 in our previous episode. If you guys have just joined us, we're busy here with circle geometry. We're doing example number 3. Okay, this is our last segment for today's show, but it is not the final episode on circle geometry. We will be continuing with this in our next episode. Okay, so find x, y, z. Like I said, let's identify and let's work out a structure on how we're going to attack x, y, z. We've got a circle, we've got a cyclic triangle, meaning all 3 points. We've got a tangent, we've got radii. We've got a host of information here, guys. So basically, the more information we have, the easier it's going to be for us to identify the unknowns. So let's start filling in information onto our diagram in order to assist us to get to our solution. Let's start with the knowns. Our known is 62 degrees. Now, what do we know? We know, look at your diagram, from the theorems that were given to you before. Line drawn from a center of a circle to a tangent. You've got a tangent. You've got a radius. And what was one of the theorems? That a radius is always perpendicular or 90 degrees to a tangent. A radius is always 90 degrees to a tangent. So we know that this whole angle here must be 90 degrees. Okay, don't worry, yes, we know that what x is going to be. But let's first identify what's given on our diagram. We also have this angle here to be 62 degrees. And we have a tangent and we have a chord. And one of our theorems that we had was angle between tangent and chord is equal to the angle. So angle, that's your chord, PB being your chord, PT being your tangent, or MT being your tangent. Angle between tangent and chord, there's it, your 62 degrees, is equal to the angle subtended at the circumference in your alternate segment. So therefore, if that is 62 there, this angle here being 62, obviously angle between tangent and chord is equal to the angle subtended in your alternate segment. So we know, and that is one of our requirements to find out the value of z. And we already know that it's 62. We're going to be structuring it down. We're going to be writing it down on the side in order to achieve our 6 marks by finding the value of x, y, and z. Okay, and obviously we know we've got there's x, there's y, there's z. Can we find x? Can we find x? Yes, we can. This whole angle is 90. So in our justification, you can start with x, you can start with z, you can start with y, in any order, totally up to you. What comes to you first is what you start writing down. So to me, x would come first, right? So I'm going to say OP is 90 degrees, OP is 90 degrees to PT. Why? Why are we saying that? Because a radius is 90 degrees to a tangent. That is the theorem, that is our reason. Now that we got these two, add up to 90. Therefore, x plus 62 equals to 90. Therefore, x plus 62 is equal to 90. Therefore, simple equation, x is equal to 90 plus 62 comes on the other side as minus 62. Therefore, x is equal to 90 minus 62, and we all know 28 degrees, right? Because 62 plus 28 will give me 90. So there we go. We've got x to be 28 degrees. Angle x is 28 degrees. What else can we now find, or what else can we conclude? We know that z is also equal, z is equal to 62. Tangent-chord theorem. And it's a direct link. It's not an indirect link, it's a direct link to our theorem. Our theorem stated angle between tangent and chord is equal to the angle subtended in the alternate segment. So angle Z is equal to 62 degrees. Why are we saying it? Tangent-chord theorem. There we go. 62 degrees, 62 degrees. Which is the only angle that is now short, that we are short of? We are now short of angle Y. There are two ways, I don't know if you've identified it, by looking at the diagram, there are two ways of getting to angle Y. Can you identify the two ways? Can you identify two ways of getting to Y? Hear me out. OP, the line, is equal to OB, the line. Why? They are radii. So therefore it makes this an isosceles triangle. So if x is 28, B2 will be 28. That's an isosceles triangle. And then we'll say 180 minus these two, the sum of these two, and that will give me y. That is method one. One way of attacking it. But to me, that would be like the garden route. That would be like the scenic route, the long way of doing it. What did I say? Select a shortest route. Two ways came to my mind in doing this. That being method one. Method two, what do I identify from our shape? The spearhead. Do you guys remember the spearhead? Go back to your theorems. The theorem that looked like this. I'm just going to, let's draw it here. So if Mr. Cameraman can delightfully just zoom into this, remember we had the spearhead. And what did we say there in that theorem? We said angle at the center, exterior angle at the center is 2 times angle at the circumference. So if that was 20 degrees, this angle would be 40. Do you see the spearhead there? Here's the spearhead, guys. We've got OB, we've got OP, and it is subtending angle A. So therefore, angle at center, exterior angle at center is equal to 2 times angle at circumference. So there's your spearhead. That's your spearhead. Here we have it. We've got angle Y is equal to 2 times 62. Why is Y 2 times 62? What is your reason for that? Exterior angle at center is equal to 2 times angle subtended at circumference. And what do we have? Therefore, angle Y is equal to 2 times 62, 128 degrees. Now, whether you did it this way, so angle Y is equal to 1, so we've got X, Y, Z. There's X, there's Y, and there's Z. Have we answered the question? Yes. How many marks was this? 6 marks. Guys, we're coming towards the end of the show. I hope you guys enjoyed today's episode of circle geometry. Remember, we are doing graded set of riders, and you will notice that as we're doing our riders, we're doing easy level 1, level 2, level 3 questions. So stay tuned to our next episode on circle geometry, where we'll be doing more advanced questions that would be appearing in your exams. And like I'm saying, just to remind you, circle geometry, 50 marks out of 150. So you have to know this work. If you guys have missed any of our previous episodes or earlier on the show, please go on to itvnetworks.tv, go under the K-Way icon, double click on that, go through our previous episodes and enjoy the show. I hope you guys have enjoyed today's show thoroughly, as we have done here in studio, and we're looking forward to seeing you in our next episode. Guys, keep your comments flowing. Keep it coming at kwaymath@gmail.com. You'll see the email address coming up on your screen, kwaymath@gmail.com, or go on to the ITV Network's website and put in all your comments. Guys, keep well and enjoy math.
الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا